Okay, so questions from Dave. What simulator did you use for walking, if you used any?
So we wrote our own simulator. So my dad actually wrote the simulator, and I think it's literally using matplotlib in Python.
Oh wow,
So yeah, it's pretty basic and it's only 2D, but it was just sort of to check the whole coordinate system for the legs was working.
cool. How long did it take to build Spot Puppy?
It's probably been we've started properly building him like a few months ago, but the development, like I've got I don't know where it is, but we started developing like a leg system quite a long time ago, and we made it into a painting robot that had one arm. So the legs have been in development probably a year now.
Oh wow.
But yeah, it's been a while.
How many servo motors are there in all?
There's 13, so there's 3 per leg, and there's also one in the neck.
Right.
So yeah, there's quite a few. The red board only just made it, but the red board's been really great.
Cool. Is a gyro accelerometer used in the main loop all the time?
No, so we got the gyro stabilization working, but it took a lot of tuning to get right, and we just didn't manage to get the gyro to work stably whilst Spot was walking. So when he's walking, he's actually not stabilized with the gyro, which is something I'd love to be able to put in, but it's just been quite tricky to do up to this point because he just falls over because of some lag.
Right.
Yeah.
How much does he weigh?
Ooh, I think probably about half a kilo with the battery in him.
Oh right, it's a lot less than I thought.
Yeah, it's like, because most of it's plastic. There's the only metal is in the servos and in the pie and stuff. So it's pretty lightweight.
How long did it take to get the balancing right?
Ooh, so yeah, that took a while, and it's still not as perfect as I want it to be. But it's taken. It probably took a month to get to this point. There's 2 types of balancing we tried. So you can either lean up a slope or try and stabilize to the slope to make yourself flat on the slope. We eventually ended up using lean up the slope balance because it's what animals do, and I thought, well, animals probably know best, so copied that.
Cool.
Yeah.
Was it all coded in Python?
Yeah, all of it is Python. Yeah.
Why Python?
It's just easy to use, I guess, and it's really easy to change stuff and easy to write. I mean, also it's like, this is probably my first time ever programming a Raspberry Pi properly, so that's what I sort of thought when I thought Raspberry Pi.
Yeah. You're using standard SG90 servos. Have they been all right?
Well, we're actually using Metal Gear versions of them, but
right.
Yeah, they've been strong enough with the elastic bands in. The plastic gears just stripped like really fast, so that means the gears inside of them just became useless. They just became circular. The metal gears are a lot stronger and they don't strip, but they still weren't quite strong enough to hold them up. So that's why we put the elastic bands on the legs to sort of take off some of the weight.
Right. A message from Harry of Raspberry Biotics. I'm currently building a robot based on the Boston Dynamics handle, but my metal servo shafts are all wobbly. How did you create a secure mounting mechanism for the legs to support the weight of the robot?
So the legs, I don't know, can you see this? I think you can.
Yeah.
So the legs have the servo connects here with the servo horn.
Mm-hmm.
So that's a lot stronger than printing directly onto the plastic for the servo connectors. But also on the back there's an axle. So the axle takes a lot of the weight off the servo and stops it from bending, which happened a lot in the early versions where there wasn't an axle on the back.
Right.
Yeah.
Did you try?
So, yeah.
Sorry, go on.
Oh no, Zora. Yeah.
Okay. Did you try other gates before deciding on that one?
Yeah, so we tried a few. We tried walking and trotting were the main 2. So walking, I started programming and it sort of started working, but I decided it's probably going to be a bit slow for the Pi Wars to really compete with any of the actual robots. So I moved to trot, and trot's quite stable because the legs are the entire robot's symmetrical, so opposite legs lift up at the same time. So it's still quite a stable gait, but it's like double as fast because you're lifting 2 legs at once, not one.
Cool.
Yeah.
Question from Mark about the algorithm you use for the gyro and the accelerometer. Is it a standard sensor fusion algorithm or is it your own?
I don't know. Well, I definitely didn't invent the algorithm, but it's programmed. It's all programmed by me and my dad. It's pretty much you just add up the values from the gyro to get a rough acceleration and sort of mix in the accelerometer, which sort of pulls it towards 0 so it doesn't drift. I mean, there's probably a name for that, but I'm not sure.
Question from Dr. Footleg. Can he self-write?
No. He has a tendency to fall over and wait for us to pick him up. I think he's lazy is what it is.
Have you thought about shifting weight to help with the balance?
Yeah, so a lot of the tuning actually is trying to shift the weight around the center of gravity to try and find the perfect balance. But unless everything is secured inside of him, like the battery, that isn't particularly effective because the battery wobbles around. So when the battery is secure, that definitely helps a lot. And with the walk, we shifted the balance around to like stay over the center of the legs. But with the trot, your balance is pretty much over the center of the legs anyway, so there's no real need to move the center of gravity around.
All right.
Yeah.
Have you? Sorry. How long did it take to write the simulator?
Well, I don't think it took too long. It's I think probably like 2-3 days. It was pretty simple really. It's just like some drawing lines in matplotlib really, because the simulator doesn't actually do any calculation. It's just literally displaying the leg positions. So it's just you do an inverse kinematics and then kinematics again to get the legs back out on the simulator.
That's beyond my brain power. Do you need to keep the weight down because of the servos, or do the metal gears just take most weights that you can throw at it?
So yeah, the weight is pretty important with Spot. So the old one is a bit lighter, but it can only just hold itself because it doesn't have the elastic bands on the legs. The new one is a bit heavier than the old one, but it still, again, only just about holds itself because of the elastic bands. It's really important to get a weight. So to keep the weight down, we decided to use lots of small batteries rather than one big battery.
Mm-hmm.
Yeah, because weight's really important, and also when it's heavier, it takes longer to shift the balance around, which is not great for a small robot.
Yeah. What sort of battery life are you getting running that many servos?
So walking, constant walking, is probably 20-30 minutes. It's pretty long, but standing it can stand for a few hours.
All right.
But it does drain, so if you forget to turn it off, it will just drain itself.
Oh, this is a good one. Does he bark?
He doesn't bark. I really wanted to add like a little buzzer or something in to make him bark, but I just didn't find the space inside of him because he's really compact.
Yeah.
So I think if the competition goes ahead, I'd really love to try and like put a little buzzer in his head. But yeah. Also the pins, we might have to design a custom board or something because the red board has now got no pins spare because it's 13 servos obviously.
Oh, of course, yeah.
Yeah, we might have to find another way to control a buzzer, or maybe use the Arduino.
A question from Brian in London. Do you think making the tail longer might add some more stability, or do you think having the tail on there adds to its stability?
I don't think the tail really adds much because compared to like a lot of the components, like even compared to a servo, it's fairly light.
Yep.
I mean, if I were to make a bigger tail and maybe put some servos in it, that could potentially assist with balance, but I'm not really sure how to do that. I would love to, but that would be quite a challenge. I think it would be quite cool to see if it would work. But the tail at the moment doesn't really assist with balance. It's just sort of for show.
Yeah. What's something about articulation? Basically, can he sit?
He can sit. I think he sits in the video that was shown earlier. I'm not sure.
Okay.
But he does sit, and it's actually quite a good way to conserve battery life. So it's useful.
Have you found any limitations in the Raspberry Pi hardware itself when coding it? Are you hitting any upper limits on the CPU and that kind of thing?
Not really, because it's actually quite simple calculations. It's just a bit of maths, really. It's not really anything really compute heavy. The one of the compute heavy bits is the eyes. That's the screen. So we just put that on Arduino Nano. So because the eyes are necessary. But yeah, it seems to work pretty well. It did get quite hot at the moment. I might add a fan into the back case because it's not open and there's not that much airflow into the case.
Yeah, you just make the tail lighter and have the fan pointing out the back. That'll make it wag.
Yeah.
What's the? Oh wait a minute. Does he sit by the 3D printer and beg for filament scraps?
Oh yeah, all the time. He's greedy.
So what's your future vision for Spot, the next version?
Well, I would love to do some sort of injection molding. Would be quite cool, so I could actually make kits for him. That would be very cool. And also I'd like to. Oh yeah, the other major thing I'd like to do is make the squash balls of the feet, but they're very heavy. So I'd like to mold some little rubber feet out of silicon or something. That would be useful. Yeah, I think. Oh yeah, I'd also print them out of ABS because PLA is just melted. So as you can see, this is completely bent. This joint, so it just falls off at the moment. I need to fix that.
How does it cope with obstacles of different kinds?
So it's surprisingly stable on rough terrain when you spread the legs a little bit.
Yep.
It doesn't actually need that much balance for fairly rough terrain. Its biggest issue is surprisingly super smooth terrain where it can't quite get enough traction because the legs slip around. Because when it's on rough terrain, the legs grip, and it usually has a high enough step height to just walk over most obstacles. But on smooth terrain, a lot of the time it does slip.
So basically, we shouldn't have a grease track.
No, that would be quite mean for him.
Do you think in future you might use metal parts rather than plastic, or do you think the weight gain would be too much?
Well, I don't know. I think metal could work because aluminium's fairly light, and because it's metal, it's a lot stronger. You could also make it a lot thinner, all the parts.
Yep.
So I do think that would be a possibility, but I'd probably have to redesign a lot of the stuff to work with cutting and bending metal rather than 3D printing metal because that tends to be fairly heavy, I think.
Yeah. I think somebody asked, are you using any deep learning models in it, or is it purely algorithm?
No, so it's purely algorithm, but I did want to use some sort of deep learning where the deep learning works alongside the algorithm or something to sort of help with the stabilization. Maybe deep learning just for the balance system. Yeah. Which would be quite cool because that's one of the more complex systems in him. I would love to do that. Didn't have enough time yet, but maybe in the future.
Yeah. Did you see the Hexapod at the conference last October?
Yes.
Did you pick up any tips from it?
Well, yeah, I think it was really cool, and we got the idea for the simulator from that.
Oh, cool.
That was, so also one thing that we got from that I would love to put in Spot, but we just didn't have sort of the amount of pins really, is sensors on the feet to test when the feet are actually on the ground. That would be quite useful because sometimes he has a tendency to walk in the air, which isn't great.
Am I currently flying through the air? True or false? When you do the design part for the 3D printed stuff, what software are you using to design it?
So I'm using SolidWorks, but we did originally use Tinkercad, which was really not great. So it started to completely lag when we started to try and make really complex things, so I had to learn SolidWorks to move to that, and it's been so much easier. You can just change stuff a lot easier rather than having to change it for everything. It just all works, really.
Is it parametric? Sort of?
Yeah, so it's pretty much, it is parametric. It's like you draw a 2D shape, and everything's based on shapes, and you extrude it, and then you draw again and carry on extruding.
Oh, cool.
And at first it's quite hard to pick up, but once you get the hang of it, it's definitely a lot more just intuitive than using Tinkercad.
Um, Leo Hearn wants to know, does it fart? I assume it doesn't, seeing as it doesn't bark.
No.
Or I don't know, with that fan on it, maybe. And one last question, because I think we're coming to the end of it. How much do you know how much it can carry in terms of weight?
So it's really not much, and so we thought of that for the attachments, so like the gun. So we've got this attachment port on the front, which you pretty much plug the attachments in. And because he can't carry that much, you have rollers on the attachments that just sort of roll along the floor.
Yeah.
So that will work for everything except Pi Noon. So Pi Noon just attaches in there, and we thought you could sort of nod the head back and forwards to hit the pole to make him like jab. We thought that might be quite a cool thing to try.
Excellent. So Danny, Orion Robots, wanted to know if you had any weight left for adding some Arduino Nanos over I²C for extra input-output.
So yeah, I mean they're quite light, so we could probably fit a few more of those in, and that, I mean, we are using one for the eyes, obviously, but probably. Actually, that's quite a good idea. I might you try and put a nano in to see if we can get feet detection if they're on the ground.
Cool.
Another one, yeah.
I think that's all the questions we've got time for. So thank you ever so much for doing the talk and doing the Q&A. It's been brilliant.
Thanks for having me.
Brilliant, thank you. And I'll shut the Skype off and switch back to just me. Thanks a lot.
Okay, thanks. Bye.
Bye.
See you.